Okay, let's look at, I think, 2 more problems and we're good for today here. But this is a 4-step problem, so it might take us a little longer. So it says neutral compounds. In a neutral compound, sum of oxidation states is 0. Note that the sign of the oxidation states and the number of atoms associated with each oxidation state must be considered. In H2O, each hydrogen atom has the oxidation state of 1, and each oxygen atom has an oxidation state of -2 for 0. So it's asking us what is the oxidation state of a individual sulfur atom. So it would be BaSO4. And again, the charge here is 0, right? So the overall charge is 0. So what we can do is we can isolate these guys here. So barium has a charge of 2+. We don't know sulfur here, so it's X here. I'm gonna say X. And then oxygen, we do know, right? Oxygen has the oxidation state of -2, but we have 4 of those guys. So I'm gonna say 4 times -2. So I have 2 plus X minus 8, because 4 times -2 is -8. I can move 8 to this side to become positive X, and the X would be simply just 6 here. So my oxidation state for sulfur is going to be +6. And this will give us a, so that's going to give us the oxidation state of an individual sulfur atom. For a nitrogen atom, it's asking us now, HNO3, what's the oxidation state of N? Well, I have 0 here again, because I have the overall charge is 0. So I'm going to have oxidation state of hydrogen, which is 1, plus N, which we don't know, so it's X, plus, again, I have 3 oxygens times -2. So -2 per oxygens here. I have 1 plus X minus 6. I move 6 to the other side. I have 1 plus X, so X would have to equal 5 here. So oxidation number of nitrogen is going to be +5. And then finally for C, or actually we have C and D here actually. C is PO3. And then I don't know what that is. 3, is it 3 plus? Let me just check here. So they have plus, hold up here, this is 8. This should have been 6 here, so I think they messed up this answer here, but the second one's correct. I don't know if that's PO3 plus or 3 minus here. Let me just check. PO3 3 minus. I want to say it's a 3 minus charge, because that would mean it's a phosphite ion. So let me just say it's a 3 minus here for the sake. Again, the overall charge is going to be -3. We don't know our phosphorus, but we know that our oxygen is going to be negative, or it's going to be 3 times -2, right? We have 3 oxygens and negative. We have each oxygen contains an oxygen that has an oxidation state of -2. -3 equals X minus 6. So X here has to be equal to +3. So let's see, they got +4 here, which I don't think is correct. -3 plus 6 gives us 3. So I think they did their math wrong here. And then finally for D, I want oxidation state of C2O4. And then I think it's a 2 minus charge here. So C2O4 2 minus. If I have a charge of -2, I want the individual charge of a carbon. I have 2 of these guys here, so I'm going to say it's 2x plus 4 times -2. It's going to be 2x minus 8. So bring the 8 to the other side, I'm going to get 6 equals 2x, so x is going to equal +3. So I have +3 again. So B and C are wrong here. B and C are incorrect. So the math for B was B is equal to +6. This is going to equal +6. And for C here, C is equal to +3, not +4. Let me say they're incorrect answers here.